Hello again, everyone. In this video, we will go through the syntax of data definition language DDL for the creation and management of tables. As we discussed earlier, SQL is a standard language for all RDBMS. We will be demoing and viewing these SQL code on Postgres SQL RDBMS. If you need to download this, you can just freely download it and install it. All the instructions are given on the website. Before creating tables, we must know what are the available data types for a given RDBMS. Every RDBMS, the data types may vary slightly, but generally the families of the data type remains the same. For example, there'll be a set of data types for all numeric values, integers and floats. There'll be a set of data types for date values. There'll be a set of data type for character values. So these three are the primary or the most commonly used families of data type. And then there are other specific data types for other purposes. This is Postgres official website. This is their official documentation, and these are the data types available in Postgres. There is no need to memorize this and understand the description. You are only expected to familiarize yourself with some of the commonly used data types. For example, I would be very frequently using the integer data type. I will be very frequently using the varchar data type or character data type for character values. I will be using date data type for date values. If I ever want to store decimals, I will probably use, do we have double or float here somewhere? Let me check. So yeah, there is float. I'm sorry, there it is. So there is float. Okay, and there can be double as well. In some RDBMS, you'll have a double or decimal. So we have decimal here, or we can also go with numeric, and then we can say, okay, 4 digits with 2 decimals. We can do that. So we'll be seeing all this by example. But if you want an extensive list of data types, this is available on Postgres official website. But again, there is no need to memorize this or understand or memorize the description. No, you just need to know the commonly used DBM data types. If you remember in one of the previous classes, we had created this analysis of program and students. So a program table has these three columns: program ID, title, and duration, where program ID is the primary key. Student is another table that has about 5 columns: student ID, name, email, age, and program ID. Student ID will be the primary key, name will be not null, email will be unique, age, we're going to put a check constraint on age, and program ID will be a foreign key. A very brief few word description of all the integrity constraint is given over here. So I'm going to use this as an input, and I'm going to use this and convert this into the actual tables of Postgres using SQL language. Now, once again, we have discussed that SQL has 4 sub-languages: DDL, DML, TCL, and DCL. Our focus right now is data definition language. And in data definition language, we will be using statements like create, alter, truncate, rename, and drop. So let us start by writing the code to create these two tables. Okay, I'm going to create a table called program, and I'm going to create these 3 columns and the respective data types. The tool that we are going to use to do this is Postgres RDBMS PG admin tool, the tool that we have for Postgres RDBMS, the GUI tool. It's called PG admin. It can be PG admin 3, it can be PG admin 4, different versions exist, but the name of the tool will be PG admin. So in the search bar, if you have already installed Postgres, you simply need to write PG admin. And I have pgadmin 3 and 4 both. pgadmin 3 is a Windows based tool and pgadmin 4 is a web based tool. You can use either, okay? The end result is going to be same. A slight difference in the interface will be there. I'm going to go ahead and use pgadmin 4. So this is the GUI tool of Postgres. Same way MySQL has a GUI called Workbench. Oracle will have a GUI called SQL Developer or SQL Plus. Microsoft SQL Server has a GUI called as SSMS, SQL Server Management Studio. So you'll be learning about these different tools in level 2 of the program. This is the password you entered during installation. You have to remember this password. If you have forgotten this password, I'm sorry, I won't be able to help you. The quickest fix will be to just uninstall and reinstall. Now, this is my server, and on my server, nope, never. On my server, actually, I have two different versions of Postgres. I have 9.5 and 9.6. Again, the code that we are writing, the version will not have any big significance. Any one version is needed. And I have all these different RDBMSs on my Postgres server. So I have these many databases created on my server. Okay. So I'm just gonna delete one of the database and just not recreate one. So you can create and delete as many databases as you like. Okay. If you remember, we did a lab author publisher. I created one database for that. So all the tables are there. Garage shop. So there are different databases. You will select the database, right click and say create database. I'm going to call this database winter 2025, which is the semester that we are in. And again, the choice of the database name is entirely your choice. Whatever you prefer to call it, you can do that. And a new database should be added. And there it is. Okay. Now, if you want to write code that is executed on this database, then you're gonna select this database, right click, and you're gonna open query tool. Okay. Query tool can be opened from here as well, under here, but then yeah, if you select this and then go to query tool, it will open it on that. So here you can you see this guys? Winter 2025. So make sure that your query tool is on the database on which you want to target the SQL, right? Because you have multiple databases. Like I have multiple databases. You may not have it initially. Okay. So let us start. Let us start by writing data definition language for creating tables. This is how you write comments in Postgres. Now let us review the requirements. I need a table called program, and it should have three columns: program ID, title, and duration. Just for convenience, I copied that so that I can easily refer to it. Oh, it was not copied, it seems. Anyway, I can remember the three names, no issues. Going back. And this is how it starts. Create table, the name of the table is program. And in bracket, you're going to write the list of all the columns. The first column that I want to have in this is called program ID. And I want this column to be integer. The second is, again, this is what happens, title. The second column I want is title, and I want this column to be a varchar or variable characters of up to 40 characters. So that's your choice. You can make it 40, 60, 100. That's your choice. 40 may be small, so let me make it 60. And the last thing we want there is duration, I believe. Yeah. And duration Again, I'm going to keep duration as, again, integer. This is the minimum required code for creating a table. SQL language is not case sensitive. I prefer to write all the keywords in uppercase and all the user defined terms in lowercase. But you don't have to do it. Okay, it's not a requirement. This is just my habit. So if you know create table, I wrote in uppercase, and then the name of the table is program, and the name of the table can change. So that I have written in lowercase. Same way, all the column names I have written in lowercase, all the data types I have written in uppercase. This is just the way I was, how do I say? When I was working back in 2008, 9, our company had this standard that we had to do it this way. So I have got into that habit. If you want, you can do it, but it's not mandatory. Now, if I want to make the first column as the primary key, I would simply, the minimum requirement is I would simply write here primary key. This is the minimum requirement. If you have a two-column primary key, then you will repeat the keyword primary key twice. Just hypothetically, if you wanted a composite primary key on program and title both, you would have written like this. No, I don't want it right now like this, but some examples later on, we will have a composite primary key. So this is the minimum required syntax for a table with one primary key. Let me make it not null. I don't know. I don't think I have mentioned that over here, but yeah, let us make it not null. Okay. So this is how not null will be. Additionally, you can write constraint and then you can give a name to the constraint. I'm going to call this PK program ID. And this is purely optional. It is not mandatory that you give a name to the constraint. So this becomes your constraint name. PK program ID becomes the name of your integrity constraint. The type is primary key. So intentionally, I'm giving name to one constraint and I'm not giving name to the second constraint. This is just for you to know that it is not mandatory. It's a good programming practice to give a name, but not mandatory. Let us execute this code. And my query ran successfully. Now, this table program got created in the database, but you may not necessarily be able to see it immediately. So I'm going to expand schemas. Under schema, I'm going to have public schema, and under public schema, I have tables. So yeah, you have my program table over here, okay? Just in case if you don't have, if you're not able to see the table, you can always refresh this. Sometimes you may have to refresh that to see the tables, okay? So this is my first table program. Let us create the second table now. Now, because the second table have too many columns, I'm gonna just copy paste this and bring it here so that I don't have to switch screen again and again. And just keep it there as a reference, okay? And now let us write the code. Create table, oops. Create table, the name of the table is students and bracket and with a semicolon. And the first column that I want is student ID should be integer. And of course, this is the primary key. Name is varchar of, I think 40 should be fine. And again, you don't have to, arrange the code in this fashion. I do it because it makes it easy to understand. You can write the whole create table, student, SID, name in one line, all the SQL in one line also, no problem. It will still execute. I just like to organize the code in this fashion because it makes it easy for my students to comprehend and understand. So name varchar 40, and again, name is going to be not null. And then we have email address. I'm going to keep email address also as varchar of, I think 20 should be fine. And this should be unique, meaning every student should have a unique email address. Age, Age, I'm gonna keep integer. In fact, bit should be fine, because age will not be more than 2 or 3, digits. So bit should be fine. Uh, but just to keep it simple, I'm gonna keep it integer as well. And this should be a check constraint. Now, this is how I'm going to write a check constraint. Check followed by a condition. So whatever condition I write in this bracket, that age column must meet that condition. So I'm going to simply write that age should be greater than equal to 16. So what I'm doing now, I'm ensuring that whenever a record is inserted in this table, and if a value for the age column is inserted, it should be either 16 or higher. That's the condition, a user-defined condition that I have put on my age column. And the last one is program ID. Now, program ID will be our foreign key. It will basically reference this program ID. Okay. Again, for a foreign key, it doesn't have to have the same name. It is good if it has the same name as this column, but it is not mandatory that they have the same name. Okay. Now the syntax for foreign key is slightly lengthier and different than a regular syntax because now you are linking two different columns of most likely two different tables. So let us do that. You're going to write references. The name of the table is program. The name of the column is program ID. Okay, this is how you're gonna refer that this program ID is going to reference that program ID. This will become your parent table and this will become your parent column. And now this becomes your child table. I'm gonna execute this code just to ensure that there is no error in it. And nope, there is no error. I'm gonna refresh and expand and have a look. I have a program table and students table. So I have created two tables with all these integrity constraints. Now, mind you, this is a standard syntax of SQL. There are some variations possible. And I want to show you one variation which is very commonly used. Okay. So I'm gonna copy this and I'm gonna call this. I'm gonna call this just let's just call it students 2. Okay, let's just call it students 2, and I'm going to show you what variation is possible. So I'm going to remove the primary keyword from here. I'm going to remove this also from here. I'm going to remove this as well from here, and I'm going to remove this as well from here. So one variation in the syntax that is possible is you first create the table with all the integrity constraints. Sorry, my bad. You first create the table with only the columns and the data types, and then you start mentioning all the constraints. You simply write constraint, and now you have to, say the name of the type of the constraint. For example, it is primary key, and then in bracket, which column is the primary key? The student ID. Again, constraint, email. So email was what? Unique. Again, it is not case sensitive, guys. Email is unique. Then again, constraint age was simply check age is greater than equal to what? 16. And this is where it becomes different now. Constraint, you're gonna say foreign key, which is the child column. In this case, the child column is program ID. And then again, you're gonna say references, program table, program ID column, and that's it. So this is one more variation that is possible. You can follow either one of the two methods. You can declare the integrity constraints with the column at a column level, or you can use this syntax where you first declare all the columns and data types, and then you declare all the constraints together. In this, you should have noted that I did not remove the not null constraint from this. And that is the specialty or a unique requirement of not null constraint, that not null constraint must be declared with the column declaration. Not null constraint cannot be declared at the bottom. Okay. Second, if you want to have a composite primary key, you can write the second column name here. Okay. Same way, if you wanted to have a two-column primary key here, okay, just hypothetically, you could have written the primary key keyword twice like this. So right now I don't have that requirement, so I'm going to just keep it not null. And I don't have any second column that should be a part of a composite primary key, so I'm going to remove that. But yes, in your lab, you do have a requirement of a composite primary key, and that is how you're going to do that. Now let me execute this. If there are any errors, we'll rectify those errors. And then there is an error. What is that? Constraint. Constraint. You know what? Yeah, I think I know what's happening here. Yeah, let me test this and then I will tell you what was the problem. Yeah, you see that? So when I remove the keyword constraint, it got created. Now the problem was, I'm gonna do a Z, Control Z. The problem is that whenever you write the keyword constraint, it becomes mandatory for you to give a name to that constraint. So I have to give this name, PKSID2, because the SID is already there, right? And unique email. Again, the constraint name is your choice. You can give any name that you prefer. And check age. Constraint name is your choice. You can give any name that you prefer. And FK program ID. And because we already have a student 2, so I'm going to just make it student 3, okay? So I'm just showing you different possibilities of the syntax. Now, yeah, this is one more thing, guys. If you have multiple SQL syntax in the query tool, and if I just, if I just go ahead and did this execute, it will start executing at the top from the first syntax. The first syntax is what? Program. So if I run this, it's going to start and it's going to give me an error. It says program already exists because it's starting to execute from the top. So when you have multiple, codes and you want to execute only a particular part of the code, it is one way is that you highlight that code. Only that code will be executed now. So now I'm just executing this part, not the above part. And I run this and there you go. So yeah, guys, so if you write the keyword constraint, then yes, you have to give a name to the constraint. Or you could have just written primary key, unique key, check. I think I showed you that as well. So what I'm going to do is I'm going to copy all this. I'm going to put it here. I'm going to put all that here and you can review and practice from it later, okay? Let me just quickly organize that. I prefer to I prefer to align my code like this. Again, this is not something that is mandatory or required. I just prefer to do it this way. And there you go. So you're going to get this file on Brightspace, okay? Now, this was all about creating a new table. I'm going to remove all of this now. Once the table is created, there are certain operations that are possible on an existing table. Operations like adding a column to a table, operations like changing the data type of a column. You can rename a column. You can remove or basically drop a column. So let us quickly have a look at these operations. So once a table is created on an existing table, you can perform these four operations. All these operations are achieved through the statement alter table and then the name of the table. So in our case, the name of the table is program. So this will remain common now, alter table program. I want to add a new column. Let me just quickly think of a possible column. So let's add phone number. Okay, let's add phone number. So alter table name, add. Now I'm not sure if the keyword column is needed because in some RDBMS it is and some it is not. So I'm going to just try this and let us see if this works. And if not, then I'll have to try a slightly different syntax. So no, it doesn't work. So because I teach four different RDBMS, and that there is a slight difference in the alter table syntax in different RDBMS. The syntax that I wrote earlier with the bracket, that's how I would do it in Oracle. Okay. So anyway, I added a column called phone number in program. You know what? This is my mistake actually. I wanted to add that in students. So now we have a classic example of a mistake that needs to be rectified. I'm going to refresh this. And after refresh, you should be able to see that I have a column called phone number, which got added by mistake. So I'll have to remove it now. Alter table program, drop column. The name of the column is phone. Again, I will have to check if this is the right syntax. And again, I'm gonna refresh this. And you see the phone number column is gone. Okay. So I actually wanted to add this in students, not in program. So I'm gonna do that change. And I'm gonna refresh students now. And it's not there. Alter table name student phone. Student. Oh, my bad, my bad. Hold on, my mistake. So the table name is students with an S, and I wrote student again. It's good that these errors are happening because most likely you're going to do the same errors. So students with an S, and I did not see earlier there was an error. I did not see notice that error. And now I'm going to refresh, and you have a phone column. Let us say phone, I want to change from integer to character. So I'm going to say alter table students modify column phone to character of 10. Again, you'll have to allow me to check this syntax. Nope. Alter table name, alter column. So in Oracle and SQL Server, we use the term modify, but I am assuming that in Postgres, I remember it is alter again. Okay, what's the happening now? Hmm. Phone to character 10. No, I doubt it. What I'm gonna do is I'm gonna pause it for a second. Just give me a minute. I'm gonna test it out. Oh yeah, okay. So I have to use the keyword type. There is a keyword called type that I have to use. I hope the screen is visible to you. So here after phone, I have to write the keyword type. And then there it is. Let us test it out. And there you go. This update was successful. The alter was successful. If you want to rename a column, okay, alter table students, rename column phone to, I'm just going to call it cell. Run it. And there you go. If I refresh the columns now, phone should change to cell. So as I was saying, these are these, and if I want to remove, I'm going to again use the same table students. I'm going to just copy all of this and put it here. So this is the altered table. These are the possible operations that you may perform on an existing table. Next, if the table has data, and if you want to remove all the data from the table, if you want to make the table empty, then you can write a statement called truncate table and then the name of the table. Right now, our table does not have any data, so this statement will not have any effect. But if any table has data, it doesn't matter. It doesn't matter whether there is one record or a million record or a billion record. If this table had data, truncate would remove all the data. The table will remain in the database as an empty structure, but the records inside the table will be removed. There is a similar statement called delete, which we'll be discussing in the DML part. But there is a difference between delete and truncate, and we'll discuss that difference later. But for now, you have to understand truncate will basically remove all records from the table. Next, if you basically write drop table student, and I'm gonna drop one of the three because I created multiple students table, if you remember. So let me refresh to confirm the name. So I have students 2, students 3. So I'm going to remove students 3. So if I write drop table students 3, it will permanently remove this table from the database. So the difference between truncate and drop is truncate is not removing the table. The table student is there. Whereas drop is removing the entire structure of the table. Data and structure both are removed. Okay. So basically removes the table with data if the data existed, okay, from the database. So this is the difference between truncate and drop. There is one more similar statement called delete, but again, there's a fine difference between delete and truncate. We will discuss that later. For now, this is all I want you to practice. Be careful when truncating and dropping tables because at least at this stage, they are not reversible, okay? Yes, there is a way of restoring a backup and all that, but it is too complex for now. So be very careful when you're doing these operations. So guys, in a nutshell, data definition language DDL consists of these 5 statements. Today we have performed these statements on a table. Later on in the course, we will work with views and indexes. And later in level 2 course, you will work with other objects like procedures, functions, package, trigger. Whenever you want to create or manage any database object like a table, view, index, you are going to use data definition language. I hope you enjoyed this video. Stay tuned for the next video.